Welcome to our overview of kindergarten, forces and interactions, pushes and pulls. When two objects interact, each one exerts a force on the other. Interactions of objects with another object can be explained and predicted using the concept of forces, which can cause a change in the motion of one or both of the interacting objects. An individual force acts on one particular object and is described by its strength and direction. Objects push or pull each other when they collide or are connected. Pushes and pulls can have different strengths and directions. Pushing or pulling on an object can change the speed or direction of its motion and can start or stop it. The first series of lessons, 1 through 8, allows students to observe the effects of different strengths or different directions of pushes and pulls on the motion of an object. By the end of Lesson 8, the goal is for students with guidance to plan and conduct an investigation in collaboration with peers to compare the effect of different pushes and pulls. The book Newton and Me, Lesson 1, follows a young boy and his dog through their day as they interact with different types of forces, including pushes and pulls. This book serves as an introduction to the types of forces that students will be learning about in future lessons. A great way to start Lesson 2 is with the Pushes and Pulls video, as this builds and reviews concepts and vocabulary that was introduced in Newton and Me. This will help students use the vocabulary as they engage in the class discussion. You might encourage students to act out or show how the different objects could be moved, a kinesthetic form of modeling. Lesson 2 also asks students to construct a labeled model showing how one of the objects moves. With your guidance, for instance, if a student selects the wagon, we would expect the model, or drawing, to include labels for the wagon itself, the wheels, the handle, and the person applying the push or pull. To represent the force applied to the wagon, the drawing should include an arrow, labeled with push or pull, showing the direction the force is applied. To this point, students have yet to actually explore a push or a pull. Lesson 3 provides students an opportunity to continue to see how pushes and pulls are used in the real world and allows them to observe how the amount of applied force impacts the distance a toy car travels. The key component to this lesson is having students develop their own definition of a push or pull using the text, the exploration, and previous experiences. Lessons 1 through 3 have provided students with physical examples of pushes or pulls caused by people and or machines. Many of us, including our students, have heard and read the story about the 3 little pigs, but have not thought about the type of force the wolf is using to blow your house down. The push by the wolf, wind, is a force that is caused in nature, and by using the story as a context, this allows students to think about how pushes and pulls exist in nature. The text in Lesson 5 shows students other examples of pushes and pulls. This lesson includes students developing a model to show how pushes and pulls are related. You may think about having students select one of the examples on page 187 as the basis of their drawing to show how the object is pushed and pulled. For example, the person is pushing the box up the ramp while gravity is pulling the box down the ramp. We see in the performance expectation that students need to be able to compare the effects of different strengths or different directions of pushes and pulls on the motion of an object. Raceway to Science, Lesson 6, provides an opportunity for students to see the effect the strength of a push has on the distance the car travels. As we facilitate this investigation, it's important for students to share their observations about what makes up an investigation. They will use these observations to help create an investigation in Lesson 7. Things that should be highlighted are an objective, a material list, a procedure, data collection, and a conclusion. While it might be tempting to simply teach the 5-step scientific method, it's important the students construct their own understanding of this process through their experiences. Lesson 7 provides students the opportunity to observe the directional effect of pushes and pulls through collisions. This lesson does not include an explicit procedure, so students are provided an experience to develop their own investigation supporting the performance expectation. Student investigation should include the models of each type of collision, the forces applied, and the resulting motion. Stop It! Explore forces on moving objects. Lesson 8 concludes the first performance expectation by having students apply what they've learned about pushes and pulls and collisions to stop the Matchbox car. This lesson also allows our students to analyze data to determine if design solutions work as intended to change the speed or direction of an object with a push or pull, the second performance expectation of this unit. The actual lesson does include video links and other resources to help facilitate the planning of this activity. Lesson 9 has students learning about how ramps work and make work easier or harder. Roller Coaster, Lesson 10, is from Picture Perfect Science and has students exploring ways to change the speed and direction of a rolling object by building roller coasters out of pipe insulation. While gravity is not specifically mentioned within the performance expectation, the concept of gravity as a downward pull towards the center of the Earth is an important concept for students to understand. The activities linked to the picture book I Fall Down allow students to physically explore how gravity affects all objects equally by dropping different objects and observing the results. When using I Fall Down, it's recommended that students get the opportunity to experience the activities, so this lesson would be anticipated to last multiple days. The materials for this unit have been included within your material kit and are outlined here on this slide. As you are planning the activities, please feel free to contact us with any questions, to request support, or share any ideas.